course, when we are talking about classification, there will be so many different types of classification tasks, right? And when there are, say, only two classes, for example, apple or orange, that becomes a binary classification task. Just ignore about the image, it got swapped over there. The binary image is the spam or not spam one, which is on the right. And the multi-class one is actually the left one. It got swapped during sketch. I don't know how, the technicality. So the multi-class means there can be different classes in which they can belong to, right? Plants, mammals, insects, birds. While in case of spam filters, an email can either be a spam or it can be not a spam, right? It goes to the inbox. So that's a binary classification task. So a binary classification basically means that there are two classes possible, that are two labels which can be assigned to a particular domain. In this case, the mails. And a multi-class classification task means there are multiple labels given to us. So there must be many objects present in our input data which needs to be labeled accordingly. Now, everybody just talks about that much amount of classification tasks, but actually if you see, there are other types as well, right? So there is something called a multi-label classification task. I'll come back to this slide after I review this one. So classification is a very broad domain. You can't just simply restrict it to only two major classifications, which is binary and multi-class classification. Now, there is something called a multi-label classification also. So as per the normal definition which is appearing on your screen, a multi-label classification basically takes any set of input data, it assigns to each sample a set of target variables. So unlike binary classification in which it is compulsory, or even in multi-class classification in which it is compulsory that out of all the possible labels, we have to assign only one label. In multi-label, we can actually assign different labels as well. So the best example is your movie reviews, right? So say take the example of the left-hand one, Harry Potter. And you can see the percentages. Basically, there are basically probability of what is Harry Potter as a domain. So horror, it is 0.02, romance is 0.02, adventure, it is 99.96, and documentary, 100% sure it's not a documentary, right? So out of all these, it's very clear which class takes over, or rather which label takes over other labels, and therefore we can classify Harry Potter as an adventure movie instead of all others. Now, imagine a movie like Doctor Strange, right? So a Doctor Strange can be an adventure movie as well, but at the same time, it has that Marvel connection to it. So must be action based also and very fictional. So it's a fantasy based also. So I can't really restrict it to only one of these labels. I have to assign it all these three labels since it belongs equally possible to all these three categories, right? So in case of multi-label classification, our major task is to identify different labels possible for the set of training inputs given to us. So this actually happens in case of Dr. Strange, which example I'm showing. This actually happens through something called sentiment analysis, in which we take different reviews, separate out keywords. For example, in this entire line, you can see journey is a good keyword, physical is a good keyword, spiritual, then brilliant, then mystic arts. These are some good keywords to actually determine whether this movie is based on action, adventure, and fantasy or not. So a machine learning model takes each review, identifies those keywords, assigns probability to each of those keywords, and then it actually assesses, yes, if I have a probability equivalent for all these three labels, in this case action, adventure, and fantasy, then I can easily assign all the labels to it. So these are really the different types of classification tasks in and all which you can come around in real life and experience, right? So today's major crux will be something called imbalance classification, which not many people talk about, right? Now, these classification tasks are very much realistic. When we are talking about real-time data, right? In which, for example, Netflix constantly we are giving data, which movies are we watching, and Netflix is constantly giving us back which movies I should watch based on the different genres or based on the different keywords which I'm providing to their server. So this becomes a highly imbalanced data, right? It becomes probably if I start watching action movie and I keep on watching 10, 20 action movies, it's not like I will always be watching action movie, right? I might actually think, okay, let's watch comedy today. but my recommender might actually end up giving me only recommendation of action movies, which is problematic to me, right? So why this happens is because my data is heavily biased. The keyword here is heavily biased towards a particular class, that is action movies, which I have watched again and again. So it's really stops recommending me that I will be going and watching a comedy movie. That is because it feels it's an out of character or rather uncharacteristic of me to watch a comedy movie after watching 35 action movies straight in a row. So a very similar this is a problematic thing, right? So probably in film cases, as you can see, this might suit well, because if somebody is watching 35 action movies, it is true that they might actually not go on to watch a normal movie like a comedy movie. So this actually works around. But now that is the beauty of data science, that you actually have to identify a use case based on how you actually fare out on your problem. So now imagine this on a real life scenario, how banks suffer, right? So in case of banks, we see that there are different fraud transactions which happen daily. So for example, I have shown a count plot intentionally over there of not fraud transactions. That means legitimate transaction, which is around how much? 2,84,000. And how many in 2,84,000 fraud we get? Only 492 such transactions exist. So when a new transaction comes to our machine learning model and says, boss, tell me whether this is a fraud or not fraud transaction. And if my machine learning model acts similar to that Netflix model, which I described in an imaginary scenario, it might say that even the fraud transaction is a not fraud transaction, which is a problematic thing to me, right? Because now I'm losing, as a bank, I'm losing my money, not to mention the reputation with my customers. So the idea of an imbalance classification is that even though there are very few instances which might be fraud, we need to clearly identify them. And such instances generally tend to have characteristics or features very different from the other basic input data. As you can see in the fish figure, which I beautifully describes, I took this from Analytics Vidya. So there are many fishes in the pond and there is only one red fish. So that red fish is rather said to be not having any characteristic features similar to other points in the same pond. So it's an outlier. And similarly, in fraud transactions, we need to determine these outliers. Now, outliers might actually be bad in some cases, for example, in Netflix one case, which I told, but not necessarily in every use case. For example, in banks use case, it is useful. Now, this is something which is of an exclusive beauty to data science as a domain in computer science. Because in computer science, if you see, everything is more or less very procedural. Even if you make something object oriented, the idea is that those object oriented things also are based on set of principles, and those principles are very constant and never change. But in data science, it's very reversal. If you are talking about data science, the principles keep on changing, and you need to keep on thinking new ideas, and you need to keep on thinking how exactly to go about those new ideas in order to bring a better product to your company or your organization or on a personal level for satisfaction. So this is the major crux of our today's entire classification agenda. Before I move on, are there any doubts? I'd like to take it. You can just put on your chat. No doubts, surely. Then I shall move on.